This article explains why much of the next generation of software may be server-based, what that will mean for programmers, and why this new kind of software is a great opportunity for startups. It's derived from a talk at BBN Labs. In the summer of 1995, my friend Robert Morris and I decided to start a startup. The PR campaign leading up to Netscape's IPO was running full blast then, and there was a lot of talk in the press about online commerce. At the time, there might have been 30 actual stores on the web, all made by hand. If there were going to be a lot of online stores, there would need to be software for making them, so we decided to write some. For the first week or so, we intended to make this an ordinary desktop application. Then one day we had the idea of making the software run on our web server, using the browser as an interface. We tried rewriting the software to work over the web, and it was clear that this was the way to go. If we wrote our software to run on the server, it would be a lot easier for the users and for us as well. This turned out to be a good plan. Now, as Yahoo Store, this software is the most popular online store builder with about 14,000 users. When we started ViaWeb, hardly anyone understood what we meant when we said that the software ran on the server. It was not until Hotmail was launched a year later that people started to get it. Now everyone knows that this is a valid approach. There is a name now for what we were, an application service provider, or ASP. I think that a lot of the next generation of software will be written on this model. Even Microsoft, who have the most to lose, seem to see the inevitability of moving some things off the desktop. If software moves off the desktop and onto servers, it will mean a very different world for developers. This article describes the surprising things we saw as some of the first visitors to this new world. To the extent software does move onto servers, what I'm describing here is the future, the next thing. When we look back on the desktop software era, I think we'll marvel at the inconveniences people put up with, just as we marvel now at what early car owners put up with. For the first 20 or 30 years, you had to be a car expert to own a car. But cars were such a big win that lots of people who weren't car experts wanted to have them as well. Computers are in this phase now. When you own a desktop computer, you end up learning a lot more than you wanted to know about what's happening inside it. But more than half the households in the US own one. My mother has a computer that she uses for email and for keeping accounts. About a year ago, she was alarmed to receive a letter from Apple offering her a discount on a new version of the operating system. There's something wrong when a 65-year-old woman who wants to use a computer for email and accounts has to think about installing new operating systems. Ordinary users shouldn't even know the words operating system, much less device driver or patch. There is now another way to deliver software that will save users from becoming system administrators. Web-based applications are programs that run on web servers and use web pages as the user interface. For the average user, this new kind of software will be easier, cheaper, more mobile, more reliable, and often more powerful than desktop software. With web-based software, most users won't have to think about anything except the applications they use. All the messy, changing stuff will be sitting on a server somewhere, maintained by the kind of people who are good at that kind of thing. And so you won't ordinarily need a computer, per se, to use software. All you'll need will be something with a keyboard, a screen, and a web browser. Maybe it will have wireless internet access. Maybe it will also be your cell phone. Whatever it is, it will be consumer electronics, something that costs about $200 and that people choose mostly based on how the case looks. You'll pay more for internet services than you do for the hardware, just as you do now with telephones. It will take about 1/10 of a second for a click to get to the server and back, so users of heavily interactive software, like Photoshop, will still want to have the computations happening on the desktop. But if you look at the kind of things most people use computers for, 1/10 of a second latency would not be a problem. My mother doesn't really need a desktop computer, and there are a lot of people like her. The win for users. Near my house there is a car with a bumper sticker that reads "Death before inconvenience." Most people, most of the time, will take whatever choice requires least work. If web-based software wins, it will be because it's more convenient. And it looks as if it will be, for users and developers both. To use a purely web-based application, all you need is a browser connected to the internet, so you can use a web-based application anywhere. When you install software on your desktop computer, you can only use it on that computer. Worse still, your files are trapped on that computer. The inconvenience of this model becomes more and more evident as people get used to networks. The thin end of the wedge here was web-based email. Millions of people now realize that you should have access to email messages no matter where you are. And if you can see your email, why not your calendar? If you can discuss a document with your colleagues, why can't you edit it? Why should any of your data be trapped on some computer sitting on a faraway desk? The whole idea of your computer is going away and being replaced with your data. You should be able to get at your data from any computer, or rather, any client, and a client doesn't have to be a computer. Clients shouldn't store data, they should be like telephones. In fact, they may become telephones, or vice versa. And as clients get smaller, you have another reason not to keep your data on them. Something you carry around with you can be lost or stolen. Leaving your PDA in a taxi is like a disk crash, except that your data is handed to someone else instead of being vaporized. With purely web-based software, neither your data nor the applications are kept on the client, so you don't have to install anything to use it. And when there's no installation, you don't have to worry about installation going wrong. There can't be incompatibilities between the application and your operating system, because the software doesn't run on your operating system. Because it needs no installation, it will be easy and common to try web-based software before you buy it. You should expect to be able to test drive any web-based application for free just by going to the site where it's offered. At ViaWeb, our whole site was like a big arrow pointing users to the test drive. After trying the demo, signing up for the service should require nothing more than filling out a brief form, and that should be the last work the user has to do. With web-based software, you should get new releases without paying extra or doing any work or possibly even knowing about it. Upgrades won't be the big shocks they are now. Over time, applications will quietly grow more powerful. This will take some effort on the part of the developers. They will have to design software so that it can be updated without confusing the users. That's a new problem, but there are ways to solve it. With web-based applications, everyone uses the same version, and bugs can be fixed as soon as they're discovered. So web-based software should have far fewer bugs than desktop software. At ViaWeb, I doubt we ever had 10 known bugs at any one time. That's orders of magnitude better than desktop software. Web-based applications can be used by several people at the same time. This is an obvious win for collaborative applications. But I bet users will start to want this in most applications once they realize it's possible. It will often be useful to let two people edit the same document. For example, ViaWeb let multiple users edit a site simultaneously. More because that was the right way to write the software than because we expected users to want to. But it turned out that many did. When you use a web-based application, your data will be safer. Disk crashes won't be a thing of the past, but users won't hear about them anymore. They'll happen within server farms, and companies offering web-based applications will actually do backups. Not only because they'll have real system administrators worrying about such things, but because an ASP that does lose people's data will be in big trouble. When people lose their own data in a disk crash, they can't get that mad, because they only have themselves to be mad at. When a company loses their data for them, they'll get a lot madder. Finally, web-based software should be less vulnerable to viruses. If the client doesn't run anything except a browser, there's less chance of running viruses and no data locally to damage. And a program that attacked the servers themselves should find them very well defended. For users, web-based software will be less stressful. I think if you looked inside the average Windows user, you'd find a huge and pretty much untapped desire for software meeting that description. Unleashed, it could be a powerful force. City of code. To developers, the most conspicuous difference between web-based and desktop software is that a web-based application is not a single piece of code. It will be a collection of programs of different types rather than a single big binary. And so designing web-based software is like designing a city rather than a building. As well as buildings, you need roads, street signs, utilities, police and fire departments, and plans for both growth and various kinds of disasters. At ViaWeb, software included fairly big applications that users talked to directly, programs that those programs used, programs that ran constantly in the background looking for problems, programs that tried to restart things if they broke, programs that ran occasionally to compile statistics or build indexes for searches, programs we ran explicitly to garbage collect resources or to move or restore data, programs that pretended to be users, programs for diagnosing network troubles, programs for doing backups, interfaces to outside services, software that drove an impressive collection of dials displaying real-time server statistics, modifications to open-source software, and a great many configuration files and settings. Trevor Blackwell wrote a spectacular program for moving stores to new servers across the country without shutting them down after we were bought by Yahoo. Programs paged us, sent faxes and email to users, conducted transactions with credit card processors, and talked to one another through sockets, pipes, HTTP requests, SSH, UDP packets, shared memory, and files. Some of ViaWeb even consisted of the absence of programs, since one of the keys to Unix security is not to run unnecessary utilities that people might use to break into your servers. It did not end with software. We spent a lot of time thinking about server configurations. We built the servers ourselves, from components, partly to save money, and partly to get exactly what we wanted. We had to think about whether our upstream ISP had fast enough connections to all the backbones. We serially dated RAID suppliers. But hardware is not just something to worry about. When you control it, you can do more for users. With a desktop application, you can specify certain minimum hardware, but you can't add more. If you administer the servers, you can in one step enable all your users to page people, or send faxes, or send commands by phone, or process credit cards, etc., just by installing the relevant hardware. We always looked for new ways to add features with hardware, not just because it pleased users, but also as a way to distinguish ourselves from competitors who didn't have direct control over the hardware. Because the software in a web-based application will be a collection of programs rather than a single binary. It can be written in any number of different languages. When you're writing desktop software, you're practically forced to write the application in the same language as the underlying operating system, meaning C and C++. And so these languages got to be considered as the languages for serious software development. But that was just an artifact of the way desktop software had to be delivered. For server-based software, you can use any language you want. Today, a lot of the top hackers are using languages far removed from C and C++, Perl, Python, and even Lisp.